Good evening, everyone. I request Kevin sir to conduct the session.
Good evening, dear students. Am I audible to everyone?
Good evening, sir.
Good evening, good evening.
Good evening, sir.
Good evening. I hope that you have gone through the concepts what you learned on the previous class. The theorems, the properties, and other things. Have you gone through this one? So last class we learned that if just a minute. Last class we learned that if the equation.
Sir, your voice is not clear.
Am I audible to everyone?
Yes, sir, you're not
Hello.
audible, sir. And your screen is very blank.
Am I audible?
Are you writing? Yes, sir, you're audible now, sir.
Okay. So if the equation is ax square, sorry, the equation is ax square plus
7 గంటలకు వస్తుందా
y square plus 2hxy plus gx plus 2fy plus c plus c is equal to 0. That is the equation. Plus c.
పోయిందట చేరిందట గయ బస్సులో లేట్ అయితే అయినా
So in order to delete the first order terms, that is 2gx and 2fy, this one, the origin has to be shifted to where we have to shift the origin? We have to shift the origin to, yes students, we have to shift the origin to, where we have to shift the origin? I'm sorry. We shift the origin to
Sir,
hf minus bg. Yes, Lord. We shift the origin to hf
wait,
minus we have to shift the origin to
HF minus GB
hf minus b by ab
AB.
minus
AB.
Yes, sir.
comma
Yes, sir.
Minus AF.
minus af by ab minus h square.
Yes, sir.
So this is what we saw in the previous class. That means if this equation is there, ax square, the equation is there, let us say this ax square plus bx plus c is equal to 0 equation is there. In that one, I have to cancel gx and fy. To cancel these two terms, I have to shift my origin to hf minus bg by ab minus h square and gs minus af by ab minus h square. We also learned the proof of this one. Now, let us say, now my equation is not, since the equation was, now the equation was ax the equation was ax square plus, the equation was ax square plus by square plus 2hxy plus 2gx plus 2fc plus this equation is we are doing. Now, now consider this equation.
Sir, your voice is breaking, sir.
Now consider the equation ax square plus by square plus 2gx plus 2fy plus c is equal to 0. That means we are considering this equation where in my present equation, what is this called as h comma xy is not there. My xy term is not there, but this is there. In this equation, now I have to delete the first order terms x and y. So in this equation, I have deleted the first order terms x and y. That is done by shifting the origin to, in this case, we shift the origin to minus, we shift the origin to minus g comma a comma f comma b. And the equation of the is, and the equation is like this: ax square plus by square plus 2gx plus 2fy plus c is equal to 0. And the equation is like, in this equation, I have to delete the first order terms. This first order terms is 2gx and 2fy. I have to delete these two terms. In such a case, I should shift my origin to minus g by a comma f by b. Instead of getting this equation, instead of giving this equation, they give this equation and then if they're telling to us to delete the first order terms, then our origin has to be shifted minus g by a comma f by b. Please write it somewhere. All these things are some of the important points we will using it to solve the problems. So similarly, instead of the given equation, this one, if I take a equation, let us say, if I take a equation, of the given equation, if I take a equation, let us say, if I take a equation, let us say, instead of this equation, if they give the equation, let us say 2hx plus 2gx plus 2fy plus c is equal to 0. In this equation, I have to delete the first order terms, these two terms. Then I have to shift the origin to minus f comma h comma g comma h. So I have to shift the origin to this one. instead of giving this equation, they're giving in the equation of form of, let us say they are given the equation, let us say they're given the equation, let us say 4xy plus 12x plus 9y plus 18 is equal to 0. This is the equation they given. So in this equation, now we have to delete the first order terms. We have to delete this two terms. Then they'll be asking, in order to delete the first order terms of this equation, where shall we need to shift the origin? We have to shift the origin to minus f by h comma g by h. So we'll find f and g value here and we'll find out where to be shifted. So here the h value will be, here h value is equal to, h value is equal to here, h value is equal to 2, equal to 2. H is equal to 2. Then gx to g is equal to 6. And f is equal to
4.5.
by 2. Origin to minus f comma h means minus 9 by 4 comma minus 6 by 2. So I have to shift my origin to this one. So this is how we'll be using the concept of this theorem and the corollary. We call these things as a corollary. From one theorem, we are taking some external subpoints that we call it as a corollary. Is this clear? The corollary, the first corollary, the first two corollaries of the theorem 2.
Sir, how f is equals to 9 by 2, sir?
2fy is equal to 9y. I have to write this one in the form of, I just have it. I have to write this in the form of 2 into f into y. So 2 into, what will be 2 into 9 by 2. That will be 2 into 9 by 2 into y. So see, this is the form of now 2fy. 2 is equal to f is how much now? My f value is 9 by 2.
Okay, sir.
Sir, then why
So-
you taking 2gx6? I mean g6.
Here it was they are given is 12x. So if you simplify this one, 2 into 6 into x. So then my g value is how much? 6. Basic maths. Please be attentive to the class. These are some basic things. Just we are equating the terms and we are finding the values. These things can be done by even 7th standard students. Some basic things. Please be attentive to the class. So we answer the first two corollaries of the theorem. Yes, students.
Yes,
We answer
sir.
the first two.
Yes, sir.
Theorem. No.
Yes, sir.
Okay. Now we'll go for next this one. This already we did in the equation itself. If my equation is, let us say, if my equation is ax square plus my equation is, let us just, my equation is ax square plus 2y square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. This is my equation. And if I am what is this called? If I am doing transformation of this equation, the equation will get changed into ax square plus already this we did the theorem also. If you take the proof of the yesterday's theorem, it is all there. 2hxy plus by square plus x1 plus y1 plus fy1 plus c 0. This if I am doing a translation of the equation, then the translated equation will become like this. You remember we did with the we did the same thing with alpha and beta, and what we did like this. Towards the end we did like this. Ax square plus 2hxy plus by square. It was alpha and beta instead of a and b, correct? No. So then this side, if you take it like this, 2 x into, it was like something with alpha, beta, and so on. Then 2y into something with alpha and beta was there. Then plus c was there. So we are taking all this thing as now one constant, and we are putting it 0 because we want to eliminate all things. So the translated equation will become in the form of ax square plus by square plus not by plus 2hxy plus by square plus by square plus gx1 plus f plus c is equal to 0. This correlate output second.
Sir, your voice is not clear.
Now is it okay?
Yes,
No, sir,
sir.
it's still breaking.
So why we are learning this correlate means sometimes they will give all the what is called as a change of coordinate, change of the axis, change of the knee coordinate, everything will give. They will ask us to find the transformed equation. That time we don't have any time to sit and do all this gymnastics and so on. We'll be using this corollaries. We'll be using this corollaries and we'll be solving it. Okay. The last of this topic, let us say now my equation is like this. My equation is like this. A into x plus alpha. My equation is A into x plus alpha whole square plus b into y plus beta the whole square is equal to c, some constant. My equation is like this. In this one, I have to remove the first order terms. In this one, I have to remove the first order terms. For that, I have to shift to origin to minus alpha comma minus beta. So if the equation of the given if the given equation is of this form, a into x plus alpha the whole square, b into y plus beta the whole square is equal to c, Then my shift my origin to minus alpha comma minus beta. So today we learned four corollaries. The first corollary is if the given equation is shifted, we have to shift it to the form of g by minus a, minus g by a by f by b. And if the equation is in the form of 2hxy plus 2gx plus 2fy plus c, then the equation is the origins to be shifted to minus f comma h and minus g comma h. Then when the equation of this form, a into x plus alpha the whole square plus b into y plus beta the whole square is equal to c, then it is done in the form of minus alpha to minus beta. We have to shift this one. Then at the same time, if we are shifting the what is called as if we are shifting the thing, what is that? If we are shifting the uh, entire equation, if we have transformation of the entire equation, then we can say that the entire equation can be written in the form of entire equation can be written in the form of ax square can be written in the form of ax square. Just a minute.
Sir. Sir.
Yes, just a minute. I'm ready. Explaining to the corollary number 3. That is the entire equation can be written in the form of ax square plus 2hxy plus by square plus the entire thing will become as a constant gx1 plus fy1 plus c will become a constant where this term has to be eliminated. So this is what we studied as corollaries of the theorem. So we'll be using all these corollaries to simplify and do the problems. Yes, any doubt, dear students?
Sir,
Yes.
you don't have given the coordinates. I mean, x comma y.
You can text. The voice is little not audible. Can text some message here. Text, can see the message. It's a equation. Whatever I'm telling is third corollary is third corollary is if my equation is let us say if my equation is ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. S is equal to 0. Then what happening? Then the entire reduced to can be transformed to the entire equation can be transformed into
Sir, your voice is not clear, sir.
ax square plus 2hxy by square plus g1 fy1 plus c is equal to means this equation after transformation the equation will become like this. The equation which is like this will become like this, will get transformed. That is what the corollary number 3 is telling. We are not telling here. The corollary number 3 is telling that the transform will become like this. Is it okay, dear students?
Yes, sir.
Shall we go for the next topic and next theorem? So please, whatever we discussed today, kindly write and keep in somewhere, especially the formula book. I would suggest, because we'll be using this concept every now and then for solving the problems. And this transformation of equations not only comes here, it will also come in algebra. Slowly, once your Govinda sir starts taking some of the topics there in the of equations, we come to the chapter there also will get this transformation of equations and so on, reciprocal equations and so on. That time, there will be using some of these geometry concepts also, especially this concept. Yes, for this one also we'll be using. We also using for reciprocal of equations. Reciprocal of equations, some other thing will come. We'll use synthetic division and we'll do something. But for this concept, we'll be using this topic again. So with this, we'll go for the next topic and discuss the theorems on rotational axis. Any doubt with regard to translation of axis in the theorems and corollaries? All clear?
Yes, sir.
Then we'll go for a what is this called as a rotation of axis. Rotation of axis, we'll go for the first theorem. When we are rotated, what will be the new coordinates? So let me draw the this one for you. Let us say this is my original axis, x, y, y dash, x dash. Just I'll reduce the length. Now I'll be drawing. Let us say I'll take some other color now. I'll be drawing a rotated axis, rotating my axis with an angle theta. I'm rotating my axis with an angle theta. My axis angle theta. So this becomes my x-axis. This becomes my y-axis. This becomes my okay. Just a minute. I take this as my short. I take as a small letter. This becomes my dash axis. That's my y dash axis. So then the same way, this becomes my small x-axis, small y-axis, small x dash axis, small y dash axis. Now look carefully. Now I'm considering a point P. Now I'm considering P. So this is my point P somewhere. Okay, let me take a little bigger line. I'm taking a line little bigger. So I'm taking a line little bigger here. Let me take this as my x-axis. I'm considering a point which is common to both the new axis and the rotated axis. So I'm considering a point P. Let my point somewhere P is here. Let my point P is somewhere here. So point P, the coordinate of point P in the new, this one is Px comma y. In the old will be capital X comma y. The new means in the old is in the original it is small x comma y. The new one is a capital X comma y. So, like as we did for theorem or translation of axis, I will draw projection of this one to x-axis and y-axis. First, I will draw to the new x-axis. For the old x-axis, I will draw it as L. And for the new x-axis, I will draw it as M. Projection as to perpendicular, I am doing it perpendicularly. Now from this M, I am going to draw projections to x-axis and y-axis. I draw projections for this one. See, this will become like this, the projection, and this becomes. I'll take this point as L. I'll take this point as. I'll take this point as Q. Intersection of these two lines, I'll take as Q. So this will become how much now? This will become 90 degree.
So can you tell me
This
where is the
and
point P?
pardon?
Point P.
Point P is here. Point P is
Okay.
here, I'll show you.
Can you look
This
at
is the
once
point
again?
P. Just a minute. Yes. Yes, Vignesh.
Yes, sir.
And text it. No problem. Since I can view the text here.
Okay, sir.
You have some doubt? Somebody has some doubt?
So here is Q.
Pardon?
So
Q is this. Q
where
is
is
this
point
point.
Q?
Point Q is the intersection of this line. This line and this line's intersection is point Q. That is
Which
the
line,
intersection.
sir?
The intersection of this line and this line. See, this point is Q. This point. That point is Q. This point is Q. This point is M. So if you want, I can draw the diagram, same diagram once again, much more this one way.
Sir, it's clumsy.
Pardon?
It's clumsy, sir. Can you draw again the diagram?
Or else wait, we will what I will do is I'll use the other one. Just a minute.
Yes, sir. Any issue, sir?
Just a minute, just a minute.
Okay, sir.
Okay. For timing, we'll draw in this one only. The same thing. That's it. This is my x-axis. My original x-axis. So this flex. This will be my small x dash, small y dash. Now what I am doing is I am rotating my this one with an angle theta. So this becomes like this. This is rotated with the angle theta, and this is rotated with the angle theta. Now I am considering one point P. Let me consider a point P somewhere here. Point P. So for this, I am drawing a projection x-axis and the new x-axis. This is my original. Okay. Before that, we have to run. This is my new x-axis. This is my new axis. This is my new x dash axis. This is my new y dash axis. What I am doing is now I am drawing projection now. The projection to the original axis projection is not for last time itself. So I am drawing a perpendicular to the axis. This is not perpendicularly for this axis. So same thing, I have to draw a projection of my new axis. So if I draw a projection to my new axis, it becomes another perpendicularly. I take this point L and this point as M. Now from M, I will draw projection to the X and Y axis. Look carefully, I will use, if you want some other color, I will use some other perpendicularly. From M, I am drawing projection to Y axis perpendicularly. So this meeting point is called as Q. That this point is called as Q. This point I take it as N. Is the diagram clear?
Yes, sir.
Yes, sir.
Okay. Now look at the diagram carefully. This becomes now 90 degree. This becomes my angle theta now. So looking at the diagram carefully, now tell me the this is my origin O. Tell me the length. If see my new on the old axis, my P coordinate is x comma y, and the new coordinate of P will be capital X comma capital Y. Tell me the value of OL and tell me the value of PL and tell me the value of PM and tell me the value of PQ. Sorry, PM and OM.
So OL value is
OL. What is the value of OL?
X comma 1.
Capital X or small x?
Small, sir.
yes,
So the
sir.
value of OL is small x. Okay. Yeah, the value of PL will be
PL.
Small
Small,
y,
small,
sir.
sir.
small y.
Yes.
Value of PM.
P.
90 degree.
As first you take value of OM.
Capital X.
Huh? Value of OM will be how much?
Capital X, sir.
H or capital X?
X,
Very
sir.
good. Capital X. And OM will be. Hey, sorry.
Sir, for OM only capital X, sir.
OM is capital X. PM is capital Y.
Yes, sir.
Don't get confused. Just we have rotated the axis. So we know all these things. We have got acute angles here. Here one acute angle is there. Here one acute angle is there. Here one acute angle is there. With right angles here. This is also right angle. Right angle. Huh? That means please write this input in your book. Once again, if I ask the values, you should be able to tell me. I am going to rub this one now. I want a diagram. Looking at the diagram, only will be solving the proving the theorem now. So we all know that when there is a right angle triangle and when there is a acute angle, let us say small acute angle, what we can do? We have a right angle triangle. Yes, we have a right angle triangle. Let us say we have a right angle triangle. We have a right angle triangle, a small acute angle. What we can do? Hmm?
Mancha.
Yes. Somebody told something. What we can do? We can use trigonometric ratios. Correct, no?
Yes, sir.
For trigonometric ratios, we need a right angle triangle with an acute angle. Correct? Last class I told you, the beginning of the class. Not beginning of the class, when we were discussing trigonometry. Remember, trigonometry itself, we spent almost 2 weeks. Basics, everything. Huh? So, when there is a right angle triangle with a small acute angle, then we can we can apply trigonometric ratios there. So we'll be going to apply the trigonometric ratios here. So first what I will do is, I'll consider triangle OMN. Just I'll tell you which is the triangle, just a minute. Look at the figure carefully. See, look at the figure here. The triangle is this one. We are going to consider this triangle. I am going to highlight it. I am going to highlight it with some other color now. Let me highlight it with color yellow. This is the color that we are going. This is the triangle that we are going to use. This one. So if I take this triangle, if I take this triangle, if I take triangle, just a minute. If I take triangle, OMN, find out what is cos theta and what is sin theta. What is cos theta there?
అవును ఎక్కడ తెత్తురు అమ్మ
What is cos theta there? Cos theta is equal to adjacent by hypotenuse, that is adjacent is ON by.
ON by
OM.
I want the value of OM. I want the value of OM.
so capital X.
Take capital X.
I want the value of OM. Value of OM is equal to
Capital X.
ON by capital X. Correct.
Yes,
So
sir.
this, if cos theta is equal to ON by capital X, if I simplify this one, this will become. Oh, okay, just a minute, I'll write this one somewhere down here. It will become. Right, so if I write like this will become. If I cross multiply everything, the entire thing will become like this. Just a minute. If I cross multiply everything, it will become like this. That is, x cos theta is equal to ON.
ON.
So this I'll take it as one equation. Sorry. X cos theta is equal to ON. I'll take this as one equation. Now same thing. Now try to find out for this triangle PQM. Tell me for the same triangle, tell me the value of sin theta for the same triangle OMN. For triangle OMN itself, value of sin theta, reduce this and tell me the value of sin theta.
So Mn equal to x
First.
cos x sin theta.
That is,
Mn
you
equal
have to
to
take this, you have to take the equation like this. What is the equation like this?
Mn by
Look at the
OM.
triangle. Take a same triangle OMN. Trigonometric ratio sin theta, that will be opposite by hypotenuse.
So
Simplify
Mn by
and get me
OM.
the equation. What will be the equation?
OM, sir.
Equation will be
Mn
Mn
equal to sin
sir.
theta.
yes sir
Sin theta, sir.
okay, that
X
is
sin theta.
x sin theta. Is it x sin theta?
Capital X sin theta.
Careful, is it x sin theta or y sin theta?
Sin theta, sir.
Y
X
sin
only,
theta
sir.
is equal to.
X sin
Just that I like what is
Sir,
written here.
how
There's no
is Y, sir?
just
yes, sir. How it is y?
about here because your diagram is there. So the thing will be here. Now this will be it will be just only. What will be left out is
So
y sin
capital
theta.
Y. Sir.
Capital Y sin theta is equal to what is the y sin theta is equal to? Tell me the thing. What is left out there? Y sin theta
MN.
is equal to.
QM, sir. QM.
No, I am speaking about triangle OMN. We not go for triangle PQM at all. It's equal to
Sir, MN, sir.
MN.
Yes, sir.
Y
MN.
sin theta.
Understood, no? Now we are going for triangle
No, sir.
PQM.
Sir,
Again,
why-
we are using the same thing. Cos theta is equal to opposite by adjacent. That will be how much? Opposite is sorry, adjacent by hypotenuse. Adjacent is QM divided by PM. So QM value I know. QM value is QM value is how much? QM value I don't know. QM I'm keeping as it is.
Sir,
I know the value of PM. What is my value of PM? My value of PM is PM value is Y.
Sir, capital Y, sir.
That's what I have written, capital Y. So the equation, if I simplify this one, this will become Y cos theta is equal to QM.
QM.
For the same triangle, if I apply sin theta is equal to opposite by adjacent. So opposite is equal to opposite is equal to which is sorry. This is sin theta. Y sin theta is equal to QM. So here I am going to apply cos theta here. Cos theta is equal to adjacent is PQ by PM. Therefore, we know the value of PM. PM is Y. Therefore, Y cos theta. Sorry.
sir,
Yes.
can you tell me in triangle OMN how it could be MN equal to Y sin theta?
Yes, sir. It would be X maybe.
X sin theta.
Sir.
In triangle.
OMN.
MN.
No, we are not taking two. What is this one is not
Sir, your voice is
OMN.
not
We are
Sound is
taking
not
the
clear, sir.
triangle of PQM. OMN, we already got two equations, no?
Yeah, sir. In that equation only, but we are
What we are
asking
doing
that.
from here, it is the triangle. What is this called as? What we are doing from here, it is a concept of this one. From here, we are doing the triangle PQM. Second triangle.
no,
No,
not that
sir.
one,
We
sir.
are
First one, sir.
Which one?
first one, sir.
Triangle
First
OMN.
triangle
Triangle
OMN.
OMN.
MN.
What is the thing? Triangle OMN.
Sir, X.
Sin
Sir,
theta,
X
sir.
sin theta is equal to
Triangle
MN.
OMN sin theta is equal. We will do from the beginning. Wait, just a minute. Triangle OMN sin theta is equal to
MN by OM.
that is opposite is MN by OM. So OM value is X. So that will be
Sir, capital X.
X sin theta is
Sin
equal
theta.
to MN.
Yes,
Yes,
sir.
sir.
This is what this one. Now we are going for triangle. Next triangle, triangle PQM.
अपने खाली उठा
For this
के
one, we are for this one we are finding cos theta. Cos theta here is adjacent by hypotenuse. Adjacent is PQ by hypotenuse is PM. So PM value is y. So it becomes y cos theta is equal to PQ. Then similarly for the same triangle, I am going to find a sin theta. Sin theta is equal to opposite by adjacent. Opposite is QM
QM by PM.
by PM. That will be equal to y sin theta. PM is what is the value of PM? Value of PM is
Sir, capital Y. Capital Y.
y sin theta is equal to QM. So we got the four equations. X cos theta is equal to ON and X sin theta is equal to MN and Y cos theta is equal to PQ, Y cos sin theta is equal to QM. So keep all these equations. Now we are coming much more. We are coming back to the graph here now. Coming back to the graph here now. I want the value of small x and small y. I want the value of small x and I want the value of small x and small y. Small x is equal to small x value is how much? OL, correct now?
Yes, sir.
OL can be written as ON minus LN,
ON.
correct now?
Yes, sir.
So I know the value of ON, I'll keep ON as it is. LN I don't know, LN is equal almost to QM.
Yes,
So
sir.
now I know the value of ON. What is the value of ON? Value of ON is equal to x cos theta
X cos theta.
minus value of QM is equal to how much? Value of QM is equal
Y
to
sin theta.
y sin
Y
theta.
sin theta.
So my small x is equal to capital X cos theta minus capital Y sin theta. Now similarly, now what will come is we'll find it for small y. Small y value is PL. Correct now? So PL can be written as in the form of P. Just a minute. PL can be written as PQ plus
Plus QL.
QL. QL is nothing but QL is equal to MN. Correct now?
Yes, sir.
Both
Yes,
are
sir.
same. So what I will do is, see here, the line is cutting here. So both are the same length. So QL is equal to MN. So PQ, what is the value of PQ? Value of PQ is equal to
Y cos theta.
y cos theta plus what is the value of QL or MN?
X sin theta.
Sin theta. So this can be written also as I'll write here y is equal to x sin theta plus y cos theta. So this is the value. This is the transform value of the coordinates. When we do rotation of axis, the transformed axis will be x will become capital X cos theta minus y sin theta, and a small y will become capital X sin theta plus capital Y cos theta. Remember, in the translation of axis, x will become h plus x, and y will become plus k. Now,
Yes, sir.
So, same thing here in the rotation of axis, theorem 1 is telling that when we do rotation of axis, the entire thing can be converted into this form. You understand how the coordinates are getting changed?
Yes,
Yes,
sir.
sir.
Okay. Kindly go through this theorem and come, and also kindly go through the theorem what we learned day for yesterday and so on. And today we learned some corollaries. Almost we learned some 4 to 5 corollaries. Please go through all these things. Come tomorrow we'll learn some corollaries of this ones. We'll be using some concept of matrix. You know matrix, no?
Yes, sir.
Yes, sir.
Have you learned to find the inverse of a matrix?
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
Okay,
I did
they
very
already
good.
taught you how to find inverse of a matrix and so on. So tomorrow we'll be learning some of the concepts of matrix. Is connected to this corollary. This theorem will be learning some corollaries which has got a concept of matrix and inverses of matrix. So thank you, students. We'll meet tomorrow. Please go through what we learned today, and especially the corollaries. Don't think the theorem is very important. Often we use corollaries, the results of the theorem. Corollaries are nothing but the results of the theorem. We'll be using that for our solving the problems. And one more theorem is there, and few more corollaries is there. With that, we'll also learn one general transformation. By Wednesday or Thursday, we'll be starting the MCQs. This transformation of this equation will be most easiest part in the entire coordinate geometry, because here no much of application is there. Once you know this theorems and corollaries, just to read the question, analyze the question, and use appropriate thing. For that, you should learn all those coordinates, shifting of origin, and so on. So we'll meet tomorrow. Thank you. Please go through the concepts and come.
Yes, sir.
Thank you, sir.
Students, please join in the next line. See you there. Bye, everyone.